All right, everyone. Welcome to day 4, and today we'll be going over physics. So our very first question, right, is which of the following is not a vector quantity? So it's important to understand for this question the difference between both scalars and vectors, right? So scalars is basically just a magnitude, which means basically just a number and no direction is being specified. Whereas a vector is both a magnitude and direction. So we have a number and we have some sort of direction like north, east, south, and west. And so from these option choices, right, acceleration, there's a direction, there's a number, velocity, same thing, momentum, same thing, even forces are vectors, right? But D, potential energy, does not take direction into consideration. So for question 1, the answer should be option choice D. Number 2, determining the area under an object's acceleration versus time graph for a fixed time interval will calculate what? So when we think about area, we're multiplying basically, think of it like a rectangle and you're doing length times width. So the units of acceleration are going to be meters per second squared, and the units on the x-axis for time graph is going to be seconds. And so once we multiply those units, meters per second squared times seconds, you should get just meters per second. Therefore, the answer for question 2, right, should be option choice D, where we're discussing a change in the velocity during a given time interval. Number 3, a small object is released from rest and reaches the ground in a time of 2.5 seconds. Neglect air resistance. What speed does the object reach the ground? So for this question, it's just going to be a simple kinematics process. And so because distance is the one thing that's not given to us, we can use equation where it's pretty much just v equals v naught plus acceleration times time. And in this case, the information provided for us is time. We have the initial velocity, which is rest, or 0. We're trying to calculate what the final speed is. And so formula, right, v is equal to v naught. In this case here, it's just rest, so 0, plus acceleration times time. Acceleration, in this case, if it's dropping to the ground, is going to be gravity. So 9.8 or approximately 10 meters per second squared. That times 2.5 should give us 25 meters per second. So the answer for question 3 should be option choice B. Number 4, a torque of 150 Newton meters causes the drive shaft of a car to rotate at 450 radians per second. How much power is produced by this torque? So what is power, right? Power is equal to work over time or energy over time. And work has units of joules on the numerator or newtons times meters. So the torque that we've already been given, right, that's basically going to be, we can rewrite the formula of power as equal to force times r, the radius, that's equal to torque over time. And now force, keep that as separate. And r radius over time, right, becomes radians per second, right? And so what we have now is all we have to do is simply just multiply 150 newtons meters times 450 radians per second to get the correct answer. You have option choice B, 67,500 watts. Lastly, number 5, why does the sky appear to be more blue when looking directly overhead than it does when looking towards the horizon? The simple answer to this is that light, right, behaves, it has this scattering phenomena. And so essentially what's going to happen is if there's more scattering, that can lead to the appropriate color, in this case here, of visualizing a blue pigment. And so that pretty much wraps up our content for day 4. So thank you all for participating.